Alrighty then, folks. In this section, we're going to look at writing equations of lines for parallel and perpendicular lines. So, parallel lines are when we compare two lines, and two lines that are parallel are lines that have the same slope, such that they will never, ever intersect. So, for example, here you have the red line and pink line. Those lines are said to be parallel because they will never intersect, and they never intersect because they have the same slope. If the slope of any one of these two were different, like let's say were to rise more or rise less, or the run would be different, they would eventually intersect. So what we're going to do is write equations of parallel lines to start. Again, parallel lines, we're going to see that they're going to have the same slope, and the only thing that's going to be different about them are their y-intercepts. So imagine here we have the slope of 3 and our y-intercepts of -3, and a little typo there. Should be a y-intercept of 4, but nevertheless we have different y-intercepts, mean they're starting from different spots but have the same rise and run. So in this example, I just want to know of these three lines, which ones are parallel. So by just eyeballing it, it kind of appears that all of these lines might be parallel, like they're not going to intersect. But parallel means that they have to have the same slope. So if I say looking at the blue line, so line A would have a slope of, well, the rise would be down 1, and the run would be over 5. So line A is going to have a slope of -1/5. If I compare that then to line B, same thing. We're going to start at this point. We're going to go down 1 and now right 4. So even though they look parallel, notice that there is a slight difference in the run. One has less of a run than the other. And then if I look lastly at the green line, so here we have line C. This one's also going to go down 1, and now if we compare the run, here my slope would be down 1 and over 5, which means that my two parallel lines would be line C and line A, because those two lines have the same slope of -1/5. All right, so now what we're going to do is we're going to write an equation of a parallel line. So what you are given is we are given a point. So let's say that I just plot a quick little graph here, just not plotting, but just sketching it. So let's say that I have a point of 5, -4, which would mean that I'm going to have a point here, right 5 and down 4. So just imagine there. And then I have a line 2x plus 3. So if I were to sketch this, 2x plus 3, let's say it looks something like this. It's got a slope of 2 and a y-intercept of 3. So what I want to try and do is I'm going to draw, or sorry, not draw, but write the equation of a, let's say, separate line, draw it here in red, that is parallel to the blue line. So parallel means, again, they're not going to intersect, but the thing that we got to remember is that they always have the same slope. So based on the equation, I know that the slope of the blue line is 2. So if I'm going to try and write the equation of the red line, I know that it also must have a slope of 2 because it's parallel. So my goal then is to write the equation of this line, and notice based on what I have a slope and I have a point. So how might I write this? Maybe I want to use point slope form. Y minus y1 equals m times x minus x1, like we did last section. Fantastic. So what I'm going to do is I'm going to use point slope form given the point and the slope of that parallel line. So I know that my point, my y value and x value would be 5 and -4. So I'll have y minus -4 equals 2 times x minus 5. And then my goal is to simplify. So again, minus -4 would be plus. I'm going to distribute the 2 to give me 2x minus 10. And then I have y plus 4. So I'm going to subtract 4 from both sides. And I'll get y equals 2x minus 14. And notice again with this line, you'll recognize that the slope of this line is 2, and that compares to the slope of this line also 2, so it's parallel. And the only thing different about those lines would be the y-intercept. So think about that starting point. One starts at 3, and one would start all the way down here at -14. All right, same thing here. I'm just not going to draw the sketch, but we have our line of 1/4 x plus 1. We pass this through the point of -4, 2. So again, if it's parallel, then I know that the slope of my red line or my new line also has to be 1/4. So using point slope form, I'm going to plug in my x and y value and my slope. So y minus 2 would equal 1/4 of x minus -4. Then to simplify, I'm going to distribute that 1/4. Again, before I do that, that would be a positive. So I'd get y minus 2 equals 1/4 x. And then 1/4 of 4 would be plus 1. And then lastly, I'm going to add 2 to both sides to get y equals 1/4 x plus 3. And there is the equation of my line. And again, notice the same slope, but different starting points. So here we're writing equations of parallel lines using that point slope form and understanding that the slope is always the same for lines that are parallel. All right, next thing we're going to look at is what's called perpendicular lines. So perpendicular lines are lines that instead of not intersecting, they do intersect. And perpendicular lines are lines that intersect at a nice, perfect right angle. And a right angle, those of you that might know angles, is 90 degrees. It forms a perfect intersection that you might see in everyday life, like the corner of a box, the corner intersection of a street. So what we're going to do is we're now going to write write equations of perpendicular lines. Now, the slopes of perpendicular lines obviously is going to be different than parallel lines. So you'll notice here I have the slope, or I have two lines that are perpendicular. One has a slope of 1/2. The other has a slope of -2. So if I compare these two, the red obviously has a slope of 1/2. To extend the blue line, I have a slope of -2, and think of that as over 1. So what opposite reciprocals means is that we're going to take the fraction 1/2, or if it's 2/1, the reciprocal means we are going to flip that fraction. So I'm going to take 1/2 and flip it and make it into 2/1. And the opposite means that I'm going to change signs. So whereas 1 is positive, 1 is negative. So opposite reciprocal means that the opposite, we are going to change the sign. Okay, so not sign, but positive or negative. And the reciprocal means we are going to flip our fraction. So that's what's going to happen for perpendicular lines. All right, so based on these three lines, I want to know which ones are parallel or perpendicular, if any. So again, we're going to look at our slopes. Slope of parallel lines are going to be equal. Perpendicular lines would be that opposite reciprocal. Line A you'll recognize is written in slope-intercept form, so I know the slope is 4. Line B and C, however, are written in standard form. So line B, we have x plus 4y equals 3. So if I want to identify the slope, what I'm going to do here is rewrite this in the slope-intercept form. So slope-intercept form, again, is y equals mx plus b. Key thing here, slope-intercept form, you have y equals. So I'm going to try and take this equation and solve it for y. So x plus 4y equals 3. I'll start off first by subtracting x. That's going to cancel here, and I'll get 4y equals, and I'm going to write this in the correct order, -x plus 3. I can't combine them because they're not like terms. Then lastly, I'm going to divide by 4. Now in front of this x, there's technically a 1, so I'll divide that by 4 and that by 4. So what I get is y equals -1/4 x plus 3/4. I know it's not the prettiest there. Key thing here is notice the slope is 1/4. So if we compare that to the red line, this has a slope of 4. This is a slope of -1/4. For the red line, it might help for you to think of that slope as 4/1. Okay? So what I know here is this. I'll draw this like this. I have my red and my blue. Because the slopes are opposite signs and the fractions are flipped, we know that these two lines are perpendicular to each other. Okay, so the red line and the blue line would be perpendicular. Now what about that green line, line C? So I have -8y minus 2x equals 16. I'm going to do this the same way, put this in slope-intercept form. So I'll add 2x, get -8y equals 2x plus 16. And then lastly, divide by -8. And I got two numbers on the other side of divide by -8 to get y equals -1/4 x. And then I would have -2. So again, considering the slope here, -1/4 x. Well, 1/4 x, notice, hey, that's the same as the blue line. Yay! So that means the blue line, line C, and the green line, we know that those are going to be parallel. So we know that those are going to be parallel because they're the same slope. But now how does the green line compare to the red? Well, if these two are parallel, and if the blue line is already perpendicular to the red, then I can say that the red line and the green line, line A and line C, those two lines are also perpendicular to each other. So parallel means that they have the same slope, and perpendicular means that their slopes are opposite reciprocals. All right, now let's go through an example of writing the equation of a perpendicular line. We're going to do the same thing we did before with parallel lines. The only thing we got to think about is the slope. So here my slope is 1 over 2. So for my new line that's going to be perpendicular, what we're going to do is we're going to find the opposite reciprocal. So opposite means that right now it's a positive 1/2, so my new slope is going to be negative. And what I'm going to do is I'm going to take that fraction and flip it. So 1 over half would become negative 2 over 1, which would just simplify down to negative 2. So my new line is going to have a slope of negative 2. And just like the previous problem, since I give you a point, our goal is to write the equation of this line. So again, I can use point slope form to write the equation, which again will simplify down to slope-intercept form. So I would have y minus my y value, which is 1. Sorry, I'll do this in red here. Y minus 1 equals my slope of negative 2 times x minus my x value, which is negative 3. Simplifying here, I'm just going to combine those to form a positive. I'd have y minus 1 equals, and then distribute that negative 2, so negative 2x minus 6. Then I'm going to add 1 to both sides, and I'd get y equals negative 2x, and then minus 5. Okay? And if you were to graph those two lines, what you would find is that those two lines are perpendicular to each other. All right, same thing here. We have, again, my lines that are perpendicular. So you're given the blue line that has a slope of negative 3. So my goal is to write the equation of the line. So negative 3, we're going to try and figure out what is the opposite reciprocal of negative 3. So what I'm going to do is the opposite. The opposite means I'm going to have a positive slope. Now, the number 3 is a whole number. We can write it as a fraction. Any whole number as a fraction is technically over 1, so negative 3 over 1. That helps me then to identify the reciprocal. 3 over 1, if we flip that, would be 1 over 3, which means my slope is going to be 1/3. So now that I know the slope and the point, I can write this in point slope form. Again, my x is 3, my y is, negative 3, my y is 5. So by using point slope form, it would be y minus 5 equals 1/3 times x minus negative 3. Again, a minus a negative would simplify to a positive. I then have to distribute. So y minus 5 equals 1/3 x plus 1/3 of 3 is 1. Then if I add 5 to both sides, I would get y equals 1/3 x plus 6. And folks, there's my perpendicular line. All right, so that's writing writing equations of parallel and then perpendicular lines. Notice the commonalities and how we're writing them. The thing we got to identify is the slope. Now let's go through a modeling problem. So here it says we have the position of a helicopter search and rescue crew is shown on the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. So here it shows blue is water. Think of the green as the shoreline. And what's happening here is that the red line is showing the path of the rescue helicopter. And by saying it's perpendicular, the angle between those two things would be 90 degrees. So I want to write an equation that represents the path of the helicopter as it flies. So notice that you are given on its path, you are given a point. So we know that it goes through a point of 14,4. So what I need to do to write the equation of this line is I got to figure out the slope of that path. Now, because I give you a graph, I can identify not only both the slope of the shoreline, but I can also identify the slope of the path itself. So I'll just show you the shoreline here. I got to identify 2 points. So on my graph, I can see a nice point right there at, looks like 1, 3. I have a point right here at 4, 1. So if I find the slope, it goes down 2 and right 3. Oops, down 2 and right 3. So I know that the green line, the shoreline, has a slope of negative 2 over 3. So if I want to find the slope of the path of the helicopter, since they're perpendicular, that slope would be the opposite reciprocal. So it's going to be positive 3 over 2. To show this, if I identify 2 points, say right there and right there, you'll notice it goes up 3 and right 2. So again, opposite reciprocals is what makes them perpendicular. Now to write the equation of this path, I'm going to take the slope of 3 over 2 and my point, and I'm going to use point slope form like we've been doing. So again, it's going to be y minus my y value, which is 4, and then equals m, which is 3 over 2, times x minus the x value, which is 14. And I'm going to get y minus 4 equals 3 halves times x is 3/2 x, and then 3 halves times 14 would be 21, so minus 21. Then I just got to simply add 4 to both sides, and I'm going to get y equals 3/2 x, negative 21, and 4 would be minus 17. And there is the equation for the path of that helicopter. All right, the 3 over 2 just represents the slope, and the minus 17 would be my y-intercept all the way down beyond my graph. So in this lesson, we looked at writing the equations of parallel and perpendicular lines. And again, it was all about the slope and then also utilizing the skills of writing equations of lines using point slope form or even slope intercept form. Got any questions? Jot those things down. We'll see you guys next time.